So for the first thing to learn about interactions, we're going to learn a new thing called magnets. Okay, in this particular section, we're going to do what is so special about magnets. We learn the characteristics of magnets, as well as how do we make magnets. So actually, what is a magnet? A magnet is an object made of either iron or steel, and can attract or repel some objects without touching them. Okay, and basically, when you hold the magnet near a very easy magnetic material, it can actually attract.
And then it can stick.
Yes, that's called attract. Or it can repel, go away.
What repel?
That means instead of stick to it, it actually goes away, force it away. So magnets come in different shapes and sizes. We have the U-shaped magnet, we have the horseshoe magnet, we can have a magnet in terms of a bar, so we call it a bar magnet. If the magnet is shaped as a button, we call it a button magnet. If the magnet is shaped as a ring, we call it the ring magnet. And if the magnet comes in the form of a rod, we call it a rod magnet. So magnet comes with different shapes and sizes. So we start to learn about the different characteristics of a magnet. The first most important characteristic of a magnet is that a magnet always attracts magnetic materials. So what is actually magnetic materials? So magnetic materials are objects that can be attracted to a magnet, as the name implied, and usually is metals such as iron and steel. But remember, if a magnet can attract non-magnetic materials, then the magnet would not attract non-magnetic materials. So what are non-magnetic materials? Non-magnetic materials by definition are objects that are not attracted to magnets. Okay, so for example, you can't stick. For example, the wood, the rubber, the glass, the plastics, and some metals such as aluminium and copper. So the question is, are all metals magnetic? Not necessarily so. Only metals that iron and steel are considered or can be attracted by a magnet.
But not pillows.
No.
Pillows are not made of iron.
Yes, pillows are not magnetic materials. So one of the most important things that we need to learn about magnet is a magnet always have two poles. Two poles means two ends. Can you see that this bar magnet have two ends?
South pole
And
north pole.
Where attraction is the strongest. So the magnetic power or the magnetism is actually strongest at the poles.
Strongest than everything.
Yes, it's stronger than at the side. So at the pole there is actually stronger at the middle of the magnet. So a magnet has two poles, and the two poles are called the north pole and the south pole. What is a magnet again? The second characteristic of a magnet is that a magnet has two poles where attraction is the strongest. So for example, look at this bar magnet over here. Okay, this bar magnet have two poles. Where are the two poles? In a bar magnet.
Pole and south pole.
Yes. So in a bar magnet, the pole is always at the end, okay, of the bar magnet.
About why they?
Can I finish first?
Yes.
So at the end of one end is called the north pole, at the other opposite end is called the south pole. So a magnet always has two poles. The two poles are called the north pole and south pole.
What are they for? What are they for?
To attract the magnetic materials. So remember the last slide, we say that the magnet has two poles, okay, where the attraction is the strongest. So if you want to attract to attract a magnetic materials, you try to use the poles, the north poles or the south poles, where, right, the attractive power is the strongest. So how do we actually do experiments to see whether, hey, are the poles is where the attraction is the strongest? Is it correct? Is it true? So this is the experiment that can prove this. So what do? We use some steel paper clips. Okay, you put the paper clips on the table, right? We point the pole of the magnet towards the steel paper clips, and this steel paper clip will be attracted to the poles of the magnet, right? Then we count the number of paper clips attracted to the poles of the magnet. Then we repeat the same thing, but this time we don't use the end of the magnet. We don't use the pole. We use the side or somewhere other places of the magnet, right? Okay, or other parts of the magnet, and see how many paper clips this other part of the magnet can pick up. So definitely the parts that pick up the most number or the most steel paper clips, right, will be the strongest magnetic forces. So eventually you'll find that the poles of the magnet attract the most number of steel paper clips, and therefore the pull of a magnet is strongest at its pole. Okay. So we now know that a magnet have two poles, the north poles and the south poles. And the poles are where the pull of the magnet is the strongest. Okay. Now, where do we find the north pole and the south pole? Where do we find the poles of the magnet? So it depends on what type of magnet. Okay. So we have this, the first one on the left. This one is called a bar magnet. It looks like a bar. Okay. And the poles, okay, on a bar magnet is always at the extreme end. So one end is a pole, the other end is also a pole. Right? If this is a north pole, the other is a south pole. If this is a north pole, the other is a south pole. So the pole is always at the end of the bar magnet. If you look at the second piece of magnet here, this is called a U-shaped magnet. Okay, a U-shape because it's really a U. Okay, if you turn it the other way, it looks like a U, right?
Yeah.
In a U-shaped
But
magnet,
that looks like a rainbow.
yes, it has two arms, like two hands, right? Two arms. The end of the arms are basically the poles of the magnet. So the poles of the magnet is actually at the end of the arms, like I pointed here. Then there is this thing called the button
Like
magnet.
that.
Yes, the button, right? Okay.
Yeah,
Now,
like
where are the poles on the button of the magnet? The poles on the button of the magnet is actually the opposite side of the button. If one side is the north pole, the other side must be the south pole. So it's the opposite side of the.
There's only one button.
Yes, there's only one button, but there are two sides of the button. One on top, one below, right? So the on top is one pole, the below is actually another pole. There are two surfaces, two
But
sides.
how about the where's the north pole and the south pole?
It's at the end of the arm. For a U-shaped magnet, it's always at the end of the arm. Can you see I point to the end of the arm here and here?
There's a magnet there.
No, there is not. There is not. Just
That one.
yes. So don't worry about that. It's at the end of each of the arm.
Can I stop it?
Yes, stop it. Remember, if we have, this is now the second, or this is actually one of the most important characteristics of a magnet. What is that? A light poles attract and light poles repel. What do you mean by a light poles attract? That means you put a north pole and a south pole together, right? We have two magnets. You put the north pole and the south pole together, they will attract each other. So unlike poles means they're different. North and south are different, right?
Why?
Beside that is the law. Beside that, why this world is like that. So unlike poles always comes together, they attract each other.
Where does this come from?
The north pole of a magnet will attract the south pole of another magnet. Okay?
Papa,
Yes?
how do
Unlike poles attract, right? So the north pole of a magnet will attract to the south pole of another magnet. What about like poles? That means north and north come together or south and south come together. If north and north come together, they will repel each other. The north pole of a magnet will repel the north pole of another magnet. The south pole of a magnet will also repel the south pole of another magnet. So like poles will repel each other. Repel each other means they won't attract, they'll go away. They go away from each other.
if you mean south, then they'll go away?
Yes, and north also they go away. Only north south they come together, understand?
Why?
It's like that. That's the law. Okay? So when we come to another characteristics of a magnet, when you hang a piece of magnet, when it's freely suspended, that means you hang a piece of magnet on a string, the magnet will come to rest in the north and south direction. That means you will just swing around until it comes to the north and south direction. Because why? Because the earth itself is like a giant magnet. So if it's a giant magnet with its own north and south pole, so the magnetic field of the earth will interact with the
Where's
freely
the north and south pole? Yeah.
No, you can't see here. The earth is so big. You see the earth have a north and a south pole. You see the earth, right? Have a north and it's like a big magnet. It has a north and a south pole. Okay, so when you have a piece of magnet freely suspended, this small piece of magnet will actually interact with the whole magnetic field of the earth. Okay, causing the magnet to point in the north and south direction.
Papa, if this is north and this is north, it will go away.
Yes.
If this is north and this is south and this one, then it will stick together.
Yes, correct. So the magnet will line itself so that it can stick together. You understand? So when the magnet is freely suspended, it will always point in the north and south direction. So what do we learn about the characteristics of magnet? We know that a magnet attracts magnetic materials, right? First. Second, we know that a magnet has two poles where attraction is the strongest, right?
It's the
North and the
South
south
pole.
pole. Then the third thing that we learned is unlike poles attract, north and south attract, right? Then like poles repel. North and north repel, south and south poles repel each other, right? And number four things we learned is when a magnet is freely suspended, it comes to rest in the north-south direction. Why? Because the Earth, because it interacts with the Earth magnetic field, and the Earth itself is a big giant magnet. Okay? Okay, we remember the last time we actually stopped at the characteristics of magnets, right? So now we're going to the next part of the magnets. It's called the uses of magnets. What do we use magnets for in
We
everyday?
need to stick
Yeah, stick, right? Where do we
to
actually use a
have
magnet?
fun.
Remember this thing?
Yeah, it's the door to stop.
Yes, it keeps the door open, right?
And then so the wall can't crack.
Yes, basically is to actually keep the door open from closing. So basically the magnet basically actually sticks to the door, right? Which is the receiving end.
What's
So
the
there's a
door
magnet
step?
and the other is actually the
What's the
magnetic
door
material.
step?
The store, this is called the door stopper.
What door stopper?
He stops the door, or he keeps the door opening. He stops the door from closing. Okay. Now in a fridge, right, we have a long thin magnet hidden inside the rubber tube, right, around the fridge door to keep the fridge door shut,
What do you mean?
to keep it
What?
closed.
What to do?
It keep it closed. It keep the fridge door closed.
What? What keep the fridge door closed?
Yeah, the thin magnet inside the fridge
Where's the
tubing.
tin magnet?
You can't see because it's inside the rubber tubing.
Oh.
Abigail, focus. Okay. Things that we actually use magnet for. We actually use it in a compass to tell you the direction, right? The needle of a compass always points to the north and the south direction. We also used magnets on our toys. For example, the chairs. Remember, you have some toys that actually works on magnet. The magnets on the chest
Elastic and leather.
yeah, it keeps them on the chessboard. Not elastic and leather. It's not about electricity. This is about magnets. Okay,
Oh.
right?
But magnet is like my squishy thing
What sushi thing?
for my snake and leather.
Yeah, stick and leather is it magnetic? I don't think so. It's squishy only. It's not magnetic.
No, I also got black thing that can stick on them.
Yes, that is magnetic definitely. So now the next part, after we finished the characteristics of magnets and the uses of magnets, next we will learn how to make magnets. Do you know how to make a magnet?
No.
Okay, we have two methods that we can use to make a magnet. One is called the stroke method, S-T-R-O-K-E. The other is called the electrical magnet method. Stroke method basically uses a stroking action. That means you touch a magnetic material with a magnet, and basically the magnet will impart magnetic power into that magnetic material. Electrical method basically uses electricity, right? It converts electric energy into magnetic energy.
Oh.
And all of here. So when we talk about the stroke method, what do? Remember I said in stroke method, the stroke method basically applies this way. Is stroking a magnetic object with a strong magnet, and essentially by stroking a magnetic object with a strong magnet, you turn the magnetic object into a magnet. Okay, look here. How do you do? Step one.
Papa?
Yeah, that means you keep on touching, keep on stroking a magnetic object like
You mean like
metal.
that?
Yes. Then that magnetic object will become a magnet. So that's how we make magnet.
You mean like that? Then it become a magnet already.
Yes. So you look at the diagram here. You keep on. You see, you're holding the bar magnet, which is red in color, and another hand using a piece of metal. So what you need to do is just keep on turning, keep on touching. For example, this is the metal material. This is the bar metal. You keep on doing this on the magnetic material, on the piece of metal, right? Sooner or later, this will become a magnet.
Papa.
Okay, remember I said there's another method of making a magnet. Another method is called electrical magnet method. Basically, the electrical method uses electrical energy, or it uses electricity, right? So in this case, what we need is a current, and therefore you need battery because you need electricity.
What current?
A current is electric current. Okay, when you have batteries, the electric current go through the external circuit
You
and
mean
goes
this
to a coil.
line is current?
Yes, this is a wire. A wire will actually use coil a long piece of wire across around an iron nail at least 20 times. Connect both ends of the wire to the battery. Test to see if the iron nail can attract any small object. So basically, this is how you make a magnet out of
You
using
mean
electricity.
this is like metal?
It becomes a magnet. This thing becomes a magnet. As long as there's electricity running through, this will be a magnet. Understand?
Through the wire.
Yes, through the wire. Yes.
Daddy. Yeah.
We'll do the experiment later together, right?
When can I do this?
So a magnet made using electricity is always called electromagnet. The electromagnet can attract magnetic object only if it's connected to a battery or source of electricity. So you need electricity for the electromagnet to attract magnetic objects. Okay? And basically, how do you make the electromagnetic stronger? You can actually increase the number of coils in electromagnet or decreasing the electric current. So where do you find electromagnet? Okay, and how do we use electromagnet? We can use the electromagnet in a scrap iron crane. We also use electromagnet in telephone or even in train like the 地铁 MRT train, right? We use electromagnet in a lot of different places.